Okay, so as we continue talking about Newton's second law, we're going to look at how do we solve these problems, because the majority of Newton's second law will focus on problem solving. There's not a lot of conceptual based ideas aside from if you take F equals ma and break it down as to how they relate. So if we just do that real quick, so here's F equals m times a, right? So if I increase the mass but keep the acceleration the same, the force will go up, right? Or the amount of force has to go up. Okay. If I increase the acceleration, that means I increase the force. So notice that the arrows go with each other. And then we talked briefly towards the end of the last video about mass and acceleration, how they work opposite each other. So the black arrows represent if I decrease the mass, the acceleration will go up. I'm making a different color besides yellow because yellow doesn't show well in here. Okay, but then if I do the opposite, right? If I increase the mass, my acceleration will go up, or go down, excuse me. So that was the purpose of that last question in the last video. Okay, well, let's now talk about how do we solve these problems. And so I've basically, through teaching, I just really learned that these problems can be solved by just 3 simple words: draw, sum, solve, right? Those are the steps, okay? And let's look at these steps. So draw means to draw the free body diagram, all right? We talked about that towards the end of the first unit 2.1. How do we, how can we visualize all these forces acting? Well, we draw a free body diagram, and it's going to identify all the forces acting on the object for all the objects involved, okay? This is important because sometimes you'll run into problems that are connected objects or there's multiple pieces to it. So you have to do it for all of the objects, right? If it's just a book on a table, well, there's only one object, but you may run into what is called an Atwood machine, where you have 2 masses passing over a pulley. So you just have to make sure that you look at all of the objects, okay? Step 2 is to sum the forces, okay? And so this brings in the m times a portion, right? So during this step, you're going to find an equation that represents the net force, right, in both directions, okay? And so this is key, right? You have to write it in both the vertical and horizontal directions. At this point in time, and this will be a little bit of a shout out to Colonel Dinsmore, who I learned this from way back when, back in 94, 95. I like to make a T-chart at this point in time, where I would do the sum of the forces in the x direction, right, equals m times a, and then sum of the forces in the y direction equals m times ay, okay? Now, sometimes the max and the may will be equal to 0, okay? Now, that just depends on what your situation is, right? So if it's not being accelerated in the y direction, well, you would set sum of fy equal to 0. If it's not being accelerated in the x direction, you would set sum of max in, you would set that equal to 0. Okay, technically 0 is still m times a, but it's just an acceleration of 0. Okay. Now, step 3, now you're going to solve. Okay, so solve for what you're looking for. You just may need to use information from the vertical side, use it in the horizontal side, or vice versa. Typically, when we have friction involved, you're going to look for something in the y direction to plug into the x direction, okay? And so that's just the basic problem-solving steps. And then the next bunch of videos will essentially just be how do we use that to solve ultimately dynamics problems, okay? The first one we're going to look at is tension. We're going to talk about friction. We're going to talk about inclined planes. There's just like a bunch of questions that you can run into that will focus on problem solving.